So 9.4 to 9.6, we're looking at trigonometry. Okay, trigonometry deals, for what we're looking at, with three things: tangent, sine, and cosine, which is your relationship in your right triangle between parts. We have fractions that we'll look at, but we will also on our calculator use the tangent, sine, and cosine button. As we're going through today, here I'll talk about how to put it in your calculator, as well as showing you some stuff on the calculator to make sure you're set up right and plugging it in right for your calculator. We'll just look at tangent today. Then we look at sine and cosine as we move along, and other ways to use them. So we have three parts of our triangle, right? We have the hypotenuse, right? So this side opposite the 90 is always our hypotenuse. Okay. And then we have our two legs. So we're going to refer to them as the opposite leg and the adjacent leg. Realize that that changes based on whether I'm at angle Z or at angle X, right? We won't be working from the 90. Okay, that doesn't work with our trig functions. We'll be working from one of the two acute angles, right? So your tangent is always opposite over adjacent, right? And technically it's opposite leg over adjacent leg. Because the other side is our hypotenuse, you'll normally hear me say opposite and adjacent and hypotenuse, and I won't include the leg when I say it, right? But that changes based on the angle. So here, for angle X, the tangent X, right, equals B over A, because B is opposite the X and A is adjacent to the X. The C is also adjacent to X, but that's our hypotenuse, so it doesn't count, right? When I'm working for angle Z, the tangent of Z is equal to A over B. Opposite of Z over adjacent to Z. We won't do anything with, you can't use the hypotenuse with the tangent. That comes in with sine and cosine. Right? So when we're looking at this, all right, we have three basic things that we can solve. All right. The third one actually comes up later. I like to include it in the book. I include it here. So we've gone over everything, and you have a nice thing where it shows everything, right? So I'll show how to solve each thing, right? I'm going to show how it works here. You don't really need to know that. This is so that what you're putting in the calculator makes sense, right? So the setup I care about, as far as what's here, that I expect to see. And then you should be getting the correct answer if you plug it in correctly. So the other work I'm showing you, you don't need to show me. You need to show me the setup. All right, but what I'm showing you here is so that you understand what you're doing in the calculator. All right, so here I have 5 as a side, I have 35 as an angle, and I have Y as my missing side. So I'm doing opposite over adjacent, so I have 5 over Y. I'm finding the tangent of 35. Okay, if I'm solving that, and I'm just solving for Y, and I'm just going to treat this as a number. It technically is a number once we plug it in the calculator. I'm just going to treat it as a number. All right. So to solve for this, I need to get the Y out of the denominator. So I multiply Y on both sides. That gives me Y times the tangent of 35 equal to 5. Then to get Y by itself, I'm doing 5 divided by the tangent of 35. Okay, so basically I need to plug that into my calculator. Okay. There's one of two ways you're plugging that in your calculator, depending on what you're using. All right, so I'm going to show you both. I'm going to write one in black and one in red on here. All right, and I'll talk through them a bit. If the top one works on your calculator, each of these, the top one should work on your calculator. If the second one works on your calculator, the second one should work on your calculator. All right. So here I'm doing 5 divided by the tangent of 35, and then I'm hitting equals. All right, so on a calculator like your graphing calculator, all right, I'm doing the tangent, I'm doing 5 divided by the tangent of 35. All right, that gets me 7.14. That is my correct answer. Okay. Now, some of the calculators you need to watch, some of the calculators you might need an extra set of parentheses on that tangent, depending on how the calculator reads it. Okay. The other thing you'll see, right, and these graphing calculators, and some of the other calculators, I have a TI 30X, I'll pull in here in a minute as well, does it the same way, is nice because it's actually how I say it, 5 divided by the tangent of 35. If you have a calculator like this, right, and there's other calculators that work like this, you're going to do 5 divided by 35 tangent equals. All right, so here I do 5 divided by 35 tangent equals, and that gets me the 7.14. Okay, so a couple things on this. One, you need to make sure you're in degrees. Okay, so that looks different on different calculators. This calculator, which is the TI 30X I was talking about, it's probably hard to see it on the camera, but it says degrees right there. If I want to change that, I hit the DRG button, and it has degrees, radians, and gradians. All right. Some of your science classes as you go along may use radians. You probably won't use gradients at all in high school, all right, but you want to make sure you're in degrees, all right? So I'm in degrees, and if I did it on this one, I would do 5 divided by, I hit my tangent button, 35, and my equals, right? On this calculator here, there's a little D right here, all right? And again, there's a DRG button. All right, so that changes it to an R, a G, and back to a D. All right, this one is easy to change. Watch your calculator, because this one you can accidentally hit that button, and now I'm in radians. When I do 5 divided by 35 tangent, I'm now getting the wrong answer because I'm in the wrong thing. So watch that. All right. The green one I showed is a little bit harder to change by accident. Same with your graphing calculators. Your graphing calculators, you're going to have something, it might be slightly different depending on the version of the graphing calculator I have. Here it says mode. So I hit mode and it shows me all of this stuff. I have to go down and highlight the one I want and hit enter. So like if I wanted to switch to radians, and most of your calculators by default are probably on radians, right? That's now on radians. So I want to go down, go over to degrees, hit enter, quit out of this. Quit. No, why are you not quitting? There we go. All right, quit out of that. So now it's in degrees again. There's most graphing calculators. There's no way to tell on the main screen if you're in degrees or not. All right, but if you go into mode, it should be fairly easy to see. All right, and it's harder to change that. All right, so watch that as you're going through, right, and make sure that's not changing on you. All right. Then our second thing we're looking at, right, so here I have 32 as a side, x as a side, 56 as my angle. So now, even though the variable is in the same spot, it's now opposite the angle. So I have tangent of 56 equals x over 32. So here, I need to get rid of the 32 in the denominator. I multiply by both sides. I have 32 times the tangent of 56 equals x. So I'm just doing that. All right, so if I have one of the calculators like this, I do 32 times tangent button 56 equals, right, which should get me 47.4. If I have the other calculator, I'm doing 32 times 56 tan equals. All right. If you're doing these reds, make sure you're not hitting equals in between here. All right. You're doing the tangent of 35 up here. You're doing the tangent of 56 here. All right. So if you multiply these first, it won't do that. You're here. The calculator is grouping this, all right, even though you don't see it. So watch that you're hitting equal sign where I wrote the equal sign. Right. Then our third one is we're looking for the angle. Right. And again, this is not in the homework tonight, right? But it is something we come into later. I think it's 9-6. So I wanted to, I want to show it to you all together. So here we're doing the tangent of z equals 3 over 4, right? Because I'm looking for the angle. 3 is my opposite, 4 is my adjacent. Right? So what I need to do is basically the opposite of tangent. The same way I divide by the y over here, or I multiply by the 32 to move it from side to side, I need to do the opposite of tangent to get rid of that. So on your calculators, right, most of your calculators, if you have something like this, right above it, right above this tangent, it says tan to the -1. Right? So that's what I'm doing. So again, it's going to depend on your calculator what the button is that you're hitting. All right. So on this calculator, it's a second button. All right. So I'd hit second as my button, then tangent, and then I do the math. All right. 3 divided by 4 equals. All right. So here I do second, tan. All right. So now it has, probably hard to see on the camera, but it says tan to the -1 there. I do 3 divided by 4. Hit my equals, and I get 36.869, which will round to 36.9. Now watch your graphing calculator. When I do second tangent at -1, automatically puts a parenthesis there. All right. I actually don't know what this calculator here does. If I do second tan, all right, it puts a parenthesis there as well. Some of them you might need to put the parenthesis in, right? Because so if you're finding it's doing of 3. If it's getting you a weird answer here, that's one thing to try. Make sure that's in parentheses. Because what I'm really doing here is the tangent of 0.75, which is 3 divided by 4. Okay. So watch that. Also, you might not be using second. It might be shift, like it is on this calculator or something like that. Some of them, it might even be like an alpha or something like that, depending on where it is. All right. With my other calculator, I'm going to do 3 divided by 4 equals, because I want the 0.75. So I do 3 divided by 4 equals. That gets me the 0.75. Then I do shift or second, depending on your calculator, tan equals. So shift, tan. All right. And in this case, I didn't even need to hit that equal a second time. It's a good idea to get used to doing it anyway, because there's some times where you need to. If you don't need to, it won't change your answer. All right. So as we go along with this, all right, when we go to sine and cosine, all that's going to change with what you're hitting is the button. All right. And what we're going to be giving you for a lot of these is, and you'll see this on the back of this, we'll give you a picture. What I care about is the setup and the answer. All right. So this other stuff I showed you here was showing you why we're plugging into the calculator. All right. But here, y is my adjacent side, so this is my setup. X is my opposite side, so this is my setup. Z is my angle, so this is my setup. All right. So what some of the problems look like. All right. First one says find tangent S and tangent R. Now watch instructions. It says write each answer as a fraction as a decimal, rounded to 4 places. So here I'm not actually using my tangent button. Right? What they want me to look at is the setup. So the tangent of S, right, is opposite over adjacent. So that's 60 over 25. Right? Because I'm leaving it as an answer, or as a fraction, I want that reduced, which is 12 over 5. Right? And then they ask me for a decimal rounded to 4 places. That's just 12 divided by 5. So in my calculator, all I'm doing is 12 divided by 5. And that gets me 2.4. Right? So there's not 4 decimal places there. If we were being picky, we'd make you write the couple zeros there, 2 zeros there, or around the 4 places. All right, as this, so 3 zeros after that. Right. Then the tangent of r is the other thing they asked for. Right. So the tangent of r. Now, because I'm moving my angle, my opposite and adjacent switch. So this is 25 over 60, which again reduces. Now this time it reduces to 5 over 12. When I do 5 divided by 12, we get 0.4167. And the reason they have you do it to 4 decimal places is there's a chart you can look these up on. All right, we won't be using the chart, but that's why you'll see that a lot as they're using it. Right, so the second one is the same thing. Find the tangent of B and C. Write each answer as a fraction and a decimal. Okay, so tangent of B. Right, opposite is 48. Adjacent is 14. Again, 50 is my hypotenuse, so I'm not using that. Right, this reduces to 24 over 7. And the fraction there is 3.4286. Okay, again, that's not my angle. I didn't use my tangent button. Right, the tangent of C, my opposite and adjacent switch. So this is going to be 14 over 48, which is 7 over 24 when I reduce it, and 0.2917. Now the next gets into solving it. So this says use the tangent of an acute angle to find a leg length. Right? So I'm looking for x. So when I look at this picture, what I'm thinking about is where is my angle? Right? And then how am I setting it up? When we get into sine and cosine, you also need to think of which trig function I'm using. Right now we just have tangent. So I have the tangent of 58, opposite over adjacent, so x over 21. The x is on top. So if you look at our chart over here, when x was on top, we multiplied by what was on the bottom, right? Because I need to move the 21 over here. So I'm going to do 21 times the tangent of 58. Right? When I plug that in my calculator, I'm going to get 34.95. On to the next one, all right? Real life example. There's actually times people use this to find the height of a building because you can easily find this. It's hard to find this, right? I use my trig functions. So my angle is 62, right? My opposite side is h. My adjacent side is 100, right? So this is my setup. So I'm doing 100 times the tangent of 62, right? Which gets me 188, and it says to the nearest foot, so I don't include my decimal. Right? Do watch when I'm saying tangent 100 times the tangent of 62. Again, some of your calculators, you might be putting in 100 times 62 tangent, but that's not how we say it. That's one of the reasons I prefer the graphing and the green calculator to the blue one I was showing you, because you put it in the way that you say it. Then find example 3, find the value of x. Right? So here, x is my adjacent side. Right? So I have the tangent of 31.